All right, everybody. Thank you for coming to this presentation. I have to admit, I'm not very good at this pointing thing, especially since I'm using Microsoft PowerPoint, and most of the time I code, so this might be going a little bit not too great, but we'll see. I mean, this should be pretty simple, right? So, first of all, I want to say again, thank you for coming. I will be presenting about patching the hypervisor, and it's a pretty awesome thing to do, actually. It's exciting. I mean, I really like it. I might be talking a little bit too excited, a little too fast, actually. Part of the problem is that I'm on East Coast time, I didn't get enough sleep, I've been drinking too much coffee, and I'm jittery. The other part is this is pretty awesome. So, you know, there's a couple of factors coming into this. My name is Konrad. I'm not going to let you guys try. You can play on your own time and try to say my last name, but that's okay. I work at Oracle, and I've been doing Zen for a couple of years. I've been doing, first off, I used to be the maintainer of the Zen subsystem in the Linux kernel. And then I started working more on the Zen side. I became a Zen release manager, and I'm also part now of Zen advisory board. And managing a team of people who are dedicated on making Linux and Zen virtualization the best it can be. So again, thank you very much for coming, and let's start the presentation. I will go over a couple things, and one thing, if you have a question, anytime, just stop me. And if I talk too fast, also stop me. It's absolutely fine. I'll probably go really quickly through the whole thing, and then at the end, you'll have some questions, which is great, because if I go too fast, you can always note it down, and then at the burst of feather, we can go over them, or if you have any lingering questions, and so forth. All right. So, first off, one of the things that everybody asks me is, okay, this runtime patching, you know, why do you actually need it? We have this fantastic feature in the hypervisors, which is called migration. So why don't you just take a guest and migrate over to another one, and shut down the old host, and migrate back, and you shut down and you obviously install a new version, and then everything goes peachy, and you do all this. You know, the live migration it's a normal feature that every virtualization offering has, so why can't we use this? And the answer is yes, you can absolutely do this. This is by all no means saying that you can't do it. The thing about it though is, data centers and other users of Zen have kind of sometimes grown organically, where they have these old machines and these other machines, and there's just not enough spare capacity to do that sort of thing. Or the machines are being used for a dedicated type of virtualizations. You will either have only guests in the local storage, or you do SRV, or you do a whole bunch of other things, and therefore you can't do it. And the other part is, well, that's what a system admin wants to do, so he is the boss. And that's what it kind of comes down to. We really want to make sure that if you have this long-running virtualization guest and you don't actually want to migrate it because you have other needs to it, well, we should allow you to do that. So we should be able to patch your hypervisor with any patches, especially security patches, so that you are not at risk of having somebody attacking and getting outside of the Zen. So that's kind of where patching has started. We were thinking about this, and especially in light of some of the things that happened last year, 2 years ago, when some of the Zen security exploits came out, and they're pretty far. I mean, you know, one of the things about security things is you write up and you say, okay, it can impact this, this, and this, but there's potentially other things you could do, and it could really take the host down, or it could compromise, but you don't know. You just don't know. So you have to be as mostly cautious as possible and assume the worst, which means in some cases we have to put down guests and so forth, but customers don't like it. So this is kind of where it came from. Now, a little bit of history. So as you see from below here, I work for Oracle, and one of the things that existed 3 or 4 years ago was a company called xSplice, a MIT startup, and Oracle bought them, and they have integrated this in part of what we give as offering to customers. You can buy Oracle support, and you get xSplice support, so that your Linux can be, without any need to migrate or shut down, can be patched, which is great. A couple of years after that, Red Hat and SUSE came aboard, and they wanted something similar to offer to the customers. And as this progressed, they realized, well, we really need to have it upstream because that is exactly what you need in Linux. You need it upstream, it will lower your maintenance, and so forth. And they came with the joint forces, and they came with something called Linux hot patching, which is kind of a merge. It's not complete, but it works pretty well. There's some things it doesn't do, and there's some things it does. The next part is, well, this is great. That works in Linux, which is fine. We have something that works in Linux. On the Zen side, well, there is Amazon, which had presentation a year ago about what they do and how they do patching. And then what I'm actually going to present. A lot of this ideas behind this presentation and also behind the design that I've been pushing forward to is based on xSplice and some of the techniques they've used. The neat thing about xSplice was that before they got bought, their code was open source and you had a Git tree. So there is a wealth of repository that can be used to kind of figure out things so that we can give it up to the upstream community and work on it. All right. Yes?
Will Amazon contribute their patch to the community?
Has Amazon contributed their work to the community? Well, yes and no. So actually, there's a person in here who is from Amazon, and he has been helping review the design document. He has also posted a patch to some of the things that I was working on. So yes, Amazon has contributed. Have they contributed with the project over here? I don't know. I haven't seen it. Okay, I haven't. But I hope that part of this discussion will be to shape up a design and everybody can contribute so we all can work towards this goal. And we all can benefit from this, which, that's the best part, right? We all have customers, and those customers demand things. And hey, if we all can join forces, that makes it much easier for us.
Is Amazon patching battery enough?
Is it better enough? Is it
Good enough?
Is it good enough?
Yeah.
Well, I don't use Amazon products. It works for their use cases, and I presume it works because they haven't had issues where have surfaced to the public that they have problems. So it's got to work.
What I remember, last year they stopped most of the machines to fix the bug.
Right, so you guys are, I don't know which one you're referring, but there was one, as we call it, Amazon reboots the world, which has the effect that all customers are angry and so forth. I don't know the details, but I know that Amazon had to reboot some of them. I don't know what the situation was, and I don't know if this technology was present at that time of day when they had these issues. That I just don't know. Keep in mind, this presentation was presented last year, and I think some of the Amazon reboot the world incidents maybe happened 2 years ago. I'm not exactly sure on the time. But, whatever it is, the point is we need something in Zen, and this is what this presentation will be talking about. All right, so for those of you who like assembler, all right, okay, I understand, not everybody, yes, okay, we have, excellent, great. So this is a very simple, well, not very simple, there was a patch, there was an issue where we ended up with a Zen security advisory, which was we're leaking information to the guest. We were basically allowing privileged information to be based on a hypercall to be released. And it was, the attack vector is different. Based on that information, you can construct something else, and then, hey, you can end up exploiting it somehow. The patch itself, and here's so on the left side, this is the function that is basically returning the information. I'm not going to go into details of what the code does, but the point being, on the left side, we have the generic code of what it is, the baseline. This is Zen without the patch. On the right side, we have Zen with the patch. And you can see it adds on a couple of lines of code. These basically are writing the value of 0 to the stack. And then it proceeds normally. At first blush, when you look at that, and you look back 5, 10 years ago to VMware or other products that do binary translation, it looks very similar. You have some operation, and it goes to the hypervisor, and the hypervisor emulates it or does something else it needs to do, and then it reruns the guest. It's very similar to it, except you can't actually have the hypervisor try to trap its own instructions and replay it and fix it up. So we need some other way of doing it. So this is the problem, right? We have old code, new code. How do we make this work in the old code? All right, the first idea that comes into mind, and so this is basically a bunch of instructions that are being executed. This one is the old instruction. This one is that old instruction. Those are the three new instructions added. And at first blush, you think, oh, great, we'll just add it in and shove the other code, and that will be all fine and peachy. Yeah, no, sorry. You know, there's this other code that expects to run here, and nope, we ended up running. So I don't know how many of you guys, maybe I'm dating myself, my age, but Code Wars, or Core Wars, sorry, where you had 4 kilobytes of memory, and one party was writing their own little assembler code, the other party was writing their own, and you were trying to own the amount of memory, and whoever had the most amount of memory or crashed the other application, they won. Well, that's exactly what this will happen. It'll break the hypervisor in imaginable fun ways, and oh man. Yeah, no. So we don't want to do that, right? Another way to you think about it is, well, we add padding to each operation, or each function. So we add some extra space in there, and then we have enough space. Yeah, well, no, because the code that you want to patch might be bigger. And so you just kind of run the race of, it just doesn't work. So an easier, much easier way is, instead of doing all this, why don't we just copy this new code that we want to use, and in the old code, we just make a jump to the new code and say, hey, that's it. And that's pretty much what we ended up wanting to do. You know, this is the new code with these new operations. Great. Then we have the old code with the old operations. And we want to figure out the offset, because what we want to do is have a nice little jump to this code. So whenever anybody calls this old code, it jumps straight back into this new code and it executes it. Now, you could do it also, you know, for functions. We basically just, the thing we have to add is these 5 new bytes. You can even do it for code, for data. You can add new data. You can change, for example, an option. All right. All you guys are now experts. You know exactly what hypervisor patching is. It's that simple. It really is. You just add this in and boom, it works, right? The talk is done. No, it unfortunately doesn't work that way. There is a whole host of little complexities before we can get to this beautiful picture of being able to, of being able to just add this in. We have to do a whole bunch of other things around it to make this work in a sensible way without causing the hypervisor to crash. And that's the problem. The next couple of slides that I'm going to go over are going to be more about roadmap and what the design document has and where we are going to go and how I envision it to be done. And there's been a discussion on the Zen development to also shape this of how we as a community want this to happen. The end result, of course, is you just want it to be as simple as possible and patch the hypervisor, and that's the end result. That will be the end result. Now, the little complexities I spoke about, one of the things that happens in binary code is it's not just code that runs, but you also have, whenever code is being loaded, there is some form of figuring out offsets of a function calling a function calling a function. And for normal applications, say you write your own user application that just does a printf hello world, when that is being loaded, or whenever that's being compiled, you have to figure out the offset of where it goes in what library, what the virtual address will be, all of that sort of thing has to be figured out. I am simplifying this a lot because there's a lot more behind it, but it pretty much is you got to figure out the offsets, you got to put it in, you got to put it in the code. That is something we don't have in the Zen hypervisor because it never ever wanted to have modules, because that's what we're adding. We're adding module support. We want to be able to take some binary code and stash it in a hypervisor and say, this is it. You gotta make this code be viable and be able to run. Therefore, you have to link where this new code calls another function. You have to put the right offsets and all that. We also have to make sure is, hey, what if I'm loading this hot patch and it's against the older hypervisor or a different build? You really don't want to do that. It's going to screw everything up. So we have to have some way of making sure that we are doing it in the right hypervisor. And of course, there's other things that people might want. Say you have a newer version of an XSA. Or there's another one behind it, and you want to patch both of them. So there's some dependency of which one you have to put. And what if they depend on each other? You know, I have all these complications. It starts getting more and more complicated. All right, it sounds like I'm making this a depressive talk, right? I'm talking about all these problems, and then, you know, where you want to patch it, and what about other CPUs, and what I guess, I'm going to skip over this one. All right. There's even more things that are depressing in some way. But, you know, the neat thing about all this is it's an interesting problem. It really is cool. All right, so here's what we have to do, right? One of the things is we can make our life much simpler by putting certain constraints on this one. When we do build time, we're making sure we use the same version of GCC. So for the one that we have the baseline, and for the patches, we use the same version of GCC. So we don't have any GCC funkiness. And we can also use some of the linker information to embed a build ID so that we can check on that and say, hey, you, Mr. Zen version, Zen hypervisor, were built against this version of linkers, and you a different one, and we won't try to load the wrong hot patch. And there's also things that have to be done to actually make this work when it comes to generating this hot patch. So one process that can be applied and that makes it much simpler is you build first the source without the patch, you get the binary out of it, great, you save it, you scroll away. Next part, you apply the patch, you build the same thing, and again, you scroll away. And then you take these functions that were generated and you compare them and say, hey, which one changed? And then you, based on that one, you figure out that offset and so forth. And then you have all this this information, and you build a payload or wherever you're going to stick this, and then you apply a signature because, you know, you don't want somebody else's payload or this binary blob with information to be applied to just some hypervisor. You need somewhere to verify that it comes from the trusted party. All right, so everybody, any questions? Yes?
For the moment you are speaking about x86, what about ARM?
What about ARM? Yes, I've been focusing on x86, but these parts are all the same when it comes to ARM. The x86 part, the x86 specific part compared to ARM specific is more of how to do the jump instructions, and that really is it, the low-level patching. Because, well, okay, I don't know that much ARM about to say the definite answer, but that's most of it. Does ARM do, on the binary stream, do we do ELF relocations? We do that, right?
We don't use that on ARM.
You use COF?
No, we use binary directly.
Okay.
But I guess that would work yet. I haven't really thought about it.
Right, as long as we can figure out the new offsets of functions, or the old functions, because we have the new code has to sometimes call different functions that, so it's just patching it with the right offset.
Sorry, this is done at build time or in
Runtime.
runtime? Okay.
So as long as we can figure, yes, sir. That answers the question, Troy?
Yes.
Okay, yes, sir.
Can you discuss any patent implications of reusing the strategy that you developed?
You mean of doing,
Since it's based on xSplice, as far as I understand it is patent coverage in your solution. Since you're
so, right, so the xSplice Git tree is where a lot of these ideas are coming from. I don't know about patent encumbrance, but
So my question is, would Oracle be willing to give the community a patent grant for using xSplice? If there are any, and if there's any doubts, would Oracle be willing to give the grant explicitly for any implication of patent rights with xSplice?
So I can tell you that the legal department would throw a fit if I mentioned the word giving a patent.
Well, that's why.
Right. So, no, they would never do that. But this is open source technology and working on the xSplice Git tree.
The reason I ask this is that if xSplice works, then it would seem to only work with Oracle solution if it is patent
I'm not sure where the patent encumbrance is coming from. See, the ideas here are pretty, I mean, they're even the same ones used in Linux hot patching.
Well, if it's borrowing the same ideas, it seemed to indicate your other slides that this was actually building upon.
So, okay, so parts of it, okay. So when I started looking at this, I looked at the upstream xSplice Git tree, which was the easiest one to look at. And then Linux hot patching came along. And the mechanism they employ, they're the same when it comes to patching code.
So you're not sure at this point if there are any patents implicated here?
I hope not. I mean, no, I don't know if there's any patents.
This has been done for a number of years, and not just by the xSplice guys. Even if Wilk does its patches, then very common implementation of HPDS is that the usage implies a cram to the patents that might be covered by that.
Sorry, legal department is not what I want to ever talk to. So, yes, sir.
Yeah, I have a technical question.
Yes, sir.
So how did you guys choose the bytes to clobber?
Bytes to clobber. You mean when we patched the beginning of the instruction?
Yeah, the new machine code, those 3 moves.
So that was the compiler doing it.
You said you built it with the old code with the bug, and you built it again with the new code with the patch,
Mhm.
with the fixed code. And then you were comparing it, and you saw that there were those 3 machine code instructions you had to add.
Yep.
So how do you know which bytes in the image to clobber, to overwrite?
So I looked at the 2 functions and saw the basically each offset. I checked each offset, and then when I had a different one, that's when I knew it was different.
It works at a function level.
Yeah.
It loads the entire new function into memory, and then it always does the jump temporally at the beginning of the old function to jump to the new function.
So the new function, where did you put that?
In new memory. I allocate new memory, stash it in there.
Did you all consider patching? So I know in malware authors and stuff, and exploits, they have the code cave at the end of the image, which is the difference between the 512 sector size on disk and the 4K page size. You have space in there also. And it's just like, it's executable, and it's a bunch of zeros.
Right, so padding basically on the end of the function. Is that what you mean?
End of the image.
End of the image.
Difference between the disk sector size and the 4K page.
Right, so we could use, I'm not sure there was a need for it. You see, part of it is we can always allocate, the hypervisor has its own memory pool. So we can just allocate memory from that and use that as a new place to load. There might be a need for that segment as a jump if the displacement is bigger than 2 gigs. And we might have to do 2 jumps, but that's more.
We're not going to need that. The combined text, data, and BSS of the hypervisor is currently less than 4 megabytes because I kind of tripled the size of it doing 2 meg alignment for super pages.
Oh, that's right, okay. Yeah, so, well, that's it. Yes, sir.
You only mentioned function changes.
Yes,
What if data structures change?
right.
Yeah,
So, right. So data structure is also an important part of it because yes, you might have data structure. Worse yet, what if your patch has a structure and adds new members to it, right?
Yeah.
How do you deal with that? Not only do you have to change the existing code, you now change the older, well, maybe not the older code, depending on how it might not use it.
Allocated data structures.
Yes.
Don't do that.
It's reboot, yeah, reboot. It will be a problem. I don't know yet exactly the recipe for solving
That's
it.
a good solution from GitHub. We have shadow structures, and then we have new code where you index with the old address, the old object, and the string name of the new member, and insert a getter. The new function will use the new getter to access that.
Okay,
shadow.
so basically somebody shadowing the old code and new code. Just the old code or just the new code?
So you replace the old code with new code, and the new code uses normal access to the old members, and a special access to a hash that contains a shadow for each new object with the new members in there.
Okay,
And only new code is going to be used.
and only new code is going to use the new members. Right,
And
okay.
you can generate multiples existing.
All right, there's the answer. Simple enough, right? Should be just a couple of days. All right, so I should probably speed up a little bit. As part of this, when I was looking at it, people wanted to know what they have because it's not like they remember what particular machine, what hot patches they have. So as part of this, when I wrote the design for it, I included some code just to say, hey, this is what we would have. It's all demoware. It really, it says applied, but it's a lie. It didn't apply anything. It just changed the state. But this is what it could look like, right? It could be a simple tool. You upload it, you say what you have, you check to verify, you verify it, and then you apply. Or you revert or whatnot. But, it seems cumbersome. You have like 4 operations to upload it. So it should be in part of Excel probably. Makes it much easier. Now, I briefly in the previous slide I said, which sections, text, and what offsets are different and how it should be patched. And we also talked about the data instructions. And it's a hard problem. It's a very hard problem. It's not something that we can solve very easily. xSplice had some ideas of how they did it, and it can certainly be borrowed. But as part of at least the first phase of this one, there's just not enough time to get that done. And it's what the idea behind it will be, at least, is that we have some form of regression tools. This is a simple call. We just get the name of the Zen extra version, in this case unstable, and then you apply this test and hey, you get hello world. Now, this is a very doctored image. It's not real, it's fake. The code actually doesn't do this yet. But this would be part of the first set of patches so that we could have all the code in the hypervisor to patch it, and then the part where you actually build it and build these hot patches are not completely yet done. So we'll allow some parts of it. And best of yet, since it allows to do some regression testing, you can put it in OSS test so that if somebody else adds new patches that break this, hey, we finally find out immediately and can fix it. Maybe in 2 or 3 days, depending on how slow the machine goes. But you get the idea. All right, so that's easy enough, right? So the other parts that are in this is, we talked about user space. You build the tools, you have the hypervisor, you have to do the patching in the hypervisor, great. And then there's the other parts is like all the stuff around that we've been discussing. So I've been posting patches, and I'm more than thrilled to discuss more of this. As we have a burst of feather, I'll be talking more about it, and we can hash out some of the issues. There'll be some discussion about it, of things we have to do and so forth. What hypercalls, we haven't decided everything completely to the stone, so it's still kind of going through it. And there's some little bit of, as I said, the RFC code. All right, questions? Yes, sir.
So it sounds like really the hardest extension is adding local support. Is that effective?
Well, it's more than that. It never is that easy, right? So yeah, loadable DLSim, pretty much, adding modules. Then you have to you have to compute offsets, you have to deal with exception tables, blah, 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 blah. A whole bunch of other things. So they're all nice to split up, and I actually created a little wiki that has a whole bunch of all these problems that I've identified. We'll add some more as, for example, the structured data changes and how to solve that one. So yeah, there's a bunch of things, right? As I said earlier, it all looks simple.
How do you anticipate? Do you anticipate this to make it for 4.7, or do you think you've got a lot more work?
Well, that's a good question, right? I am sure with everybody contributing to it, it will work in 4.7. So, as you can see the picture, I want you for xSplice development. There's always, I'm trying to make this as individual pieces to make it easier for people who are interested in this one to be able to contribute to it and work on it. And there are some companies that have already some of this code working in some fashion or another. There's some public ways that Amazon has disclosed, and there's some other companies that have a more private way of doing it. And hopefully the point will be that we all can work together and have something out. And it's a joint effort. Yes?
So what is the downside? How many new attack vectors is it at? Because adding DLSim support seems to be a big...
Absolutely 0. No. I mean, it is an attack vector can be easily exploited, right? You upload the wrong hot patch. It blows apart the whole machine, right? So there's a couple of ways that I want to make sure we don't hit that. One of the signature verification, we need that. So we can verify that it comes from a trusted source, that if it comes from Zen server, it has a Zen server certification. And it is only done through privileged domains and so forth and so forth. I mean, we have to have that. There's no other way around it. Yeah.
Maybe even stub domain or something. They can only.
Or that. I mean, there's multiple ways of doing this, but we must ensure that this is, I mean, it is like, in the Linux kernel, you can you can load a module. And the first thing your module can do is do machine_shutdown. Right? So it's a perfect exploit. You just bring the whole machine down. So we must do the same thing. We must make sure that that is not an option. Yeah. Wow. All right. Let's do you and then Jürgen.
Just have a simple question. Can xSplice patch itself?
Can it run itself?
Yeah, can it patch? Can xSplice patch itself?
Right. So I think what you mean is, say we have an old hot patch, and then you want to apply another hot patch that will modify it?
Yeah.
Okay, so one hot patch on top of another hot patch.
I think you meant the infrastructure.
How patching the infrastructure itself? Patching itself.
Right. So yes and no. Right. So no, because one of the things that we want to make sure is when we apply the patch, we don't want on the CPU call chain, so all the function stack, we don't want us to patch that because it might modify whatever was supposed to be returned and it might lead to disaster. So that's one area we must not do anything about it. So in that context, no. But there is a different way of doing this. For example, the original xSplice, as part of module loading, it would load a binary blob of instruction that would apply the patch. That could also be reused, but that would mean that we don't just load the hot patch, we also execute it. And you really have truly module support. And that part, I don't know if the x86 maintainers on the hypervisor side will look keenly on or happy not. So that really is, I haven't even thought about this, and this is something that phase 2, phase 3, it really depends. Jürgen.
Have you thought about replacing the entire hypervisor form? So just the mirror image more or less of the version and plug it to that and throw away the old hypervisor?
Right. So
yeah, more or less, but maintain the old data structure.
So yes and no. I've looked at it a bit, but this seems a much simpler way of solving it than doing that.
Then you wouldn't have any problems with hot patching, hot patched.
Right, but then in some way you add migration basically. On each structure you have to add a version field and say, hey, this is version 1, this is version 2, and I'm patching it, I need to expect these ones and I have to repatch it. So you end up adding, basically migration on the hypervisor structure levels. And it boggles my mind of how to do it properly. You and then.
Comment to that. There's a research project by Team Darmstadt in Germany doing exactly that. And I had a look at the code, and they have serialization code in all the different subsystems, and they have special code to do the structure version conversion
From A to B.
Yeah, to the new version. So it looks much more complicated than that. But it's more elaborate and complex to have a full solution.
Oh, Bjorn, right?
Yeah, I was also going to probably do some research paper from the University of Toronto a couple of years ago. It was called Hypervisor, and they did this for the looks. They basically did a KExec and had transformation code that scanned through memory, figured out all the processes, all the important metadata structures, and transformed them into data that is useful for the community. So it works, and there's a lot of work to be done. I'm not sure if that would be easier.
Go ahead.
So, this, being a Zen server engineer, this is a question that we get quite a lot with Zen server about how we would go about supporting this. The way I see it, you've got two two groups of people. You've got the group of people who never ever want to reboot a server, at which point, why do they want hot patches in the first place? They just want something that's going to stay stable. You've got the people who need to fix a security issue and then schedule some downtime. I have to admit, I don't think it's terribly interesting to take general updates via hot patch, which is too much shooting in the dark. You want hot patching for the security vulnerabilities until you can schedule some downtime. As a result, I don't think having things from changing exception tables is terribly useful.
Otherwise, you can't patch functions that contain exception tables. And you use the exception table.
But what exception tables are you talking about here?
If you, for example, if you access an MSR inside the SAM, you typically generate an exception table entry, and you have the runtime exception during the MSR access. There's fix-up code generated. And
yes, and they're all relative jumps, so you just generate a new set for the new patch.
Exactly, you need to have a small new exception table that covers the new patch functions. And you need to bring that somehow into the old exception handler.
Oh yeah, that's easy. The init stuff's still around.
Well, but you also need support for unloading, and you need to make sure that the unloading pass doesn't go after this just removed, so there are some complexities.
Right, but still, you're not talking about general changing of yeah, that is a specific example where you do need it, but things like changing a data structure, I do not care for an XSA that changes data structure. I don't think it's needed. I cannot remember the last XSA fix that actually changed the data structure.
Didn't we change one of the X's that was dealing with segments, that we changed the structure to be a union, or?
No, that was a proactive fix after the fact to make sure you never have the same problem again. But the security fix was just an extra if statement
Okay.
in it that prevented it falling down the wrong path of the union.
All right.
I think there were two XSAs where data structures were changed. It's extremely rare.
And if we could probably come up with a fix that doesn't require that.
Right. So this brings another topic, right? When you do these hot patches, you don't always have to pick exactly as the XSA is. You can pick up a different way and craft it and then have it run. That takes time and it takes knowledge to do it right. And it's absolutely something that I'm sure every vendor that is selling the service would do. But so the use cases are, yes, I think most of the majority of use cases are security exploits or potential securable exploits. There might be some other issues as well. We have to take an advice that this might expand, so make sure that we have the functionality for a lot of these use cases, as much as possible. Maybe not the first patches that come in, but as time expands. And I think it behooves us to make sure we at least acknowledge that in the design document and make sure we think it through.
Yeah, I'm not saying deliberately prevent doing that.
All right.
I reckon we can get 99% of use with just simple function patching and stuff like that.
Absolutely. Yep. Right.
I would not be a particularly nice person to talk to in Zen server if someone comes along and said, hey, I replaced spin locks in the hypervisor with hot patching and it crashed.
But it helps performance.
I guess we genuinely have that asked.
Is it a reasonable thing to expect the community to just say that you got to migrate to create all these layers of abstraction, like a big hack? It sounds like it'd be reasonable to say we don't support this and just migrate.
That's not what the customers want. Yeah. Sorry. I mean, yes, migration option, but it's not always option. You might have overcapacity problem. You might have, say, older machines and newer machines, and you only have some amount of the newer machines, and the guests have been booted up with that CPU support. You have all these fleet of old machines, but you can't migrate them because they'll crash because they try to use an operation that the old machines don't support. So then you must do something with them. You can go out and buy some more machines, sure, but that's probably not part of, you know,
It's hard to do an embargo window.
yeah, 2 weeks window. Okay, let's buy some more machines and then we can move the guests over. No, I don't think that, yeah, so this is another way. Yes, sir.
How do you say your last name? I think you need hot hatching for that.
Yeah, great. So I think you're referring to this, there you go, right? You mean my middle name or my last name?
Your middle name.
Yeah. That's pretty easy. It's just Rzeszutek. I don't know what you guys are talking about. All right. Well, I appreciate everybody paying. Oh yeah, more questions, of course. Okay. All right. I'm sorry. Well, I think yes.
You have the xSplice in Oracle. You have it in production use?
Is xSplice in production use?
Yeah.
For Linux kernel, yes.
Yeah. So you should know how often customers really want to use this.
I mean, as far as I understand, they want it all the time.
Yeah. Do they do it or do they only want it?
They use it too.
So, okay, so that's the answer. Customers are willing to update their hypervisor.
I mean, yes. We,
It's the same for the hypervisor.
right. So yeah. I mean, their customers want to have zero uptime. They want to have. They. Yeah, all right. It's sorry, wrong usage. They want full-time uptime. They don't want it to get. They don't want the kernel to go down. They want it all the time running, and you know that's what they want. And the same thing for their hypervisor. They want it all the time. They don't want to do this. Now I concur that for some things you really should not do patch updates that are just incremental patch stuff. You really should schedule downtime. And sure, sometimes that just does not work with customers. They have deadlines. You know, they can't. XSA comes in December. They can't schedule downtime. They have presents to provide. You know, Santa Claus has to fly on his sled, so you got to make that happen. All right. With that in mind, with Santa Claus flying off, thank you everybody for paying attention to my talk and contributing. It was really good. I'll have to jot those questions down. And as I said, if there's a wiki page that I'll be also updating after the BOF with some ideas of other things to be done and so forth. I'll also be posting on the Zendevel a new updated version after this summit. And if you want to be CC'd on it, please just give me your business card, or I can give you my business card if you like, so I can be included, so you can keep up on it. And if you have any thoughts, or so, by all means, please express it. All right. Thank you very much, and have a wonderful day. Thank you. Thank you.